Your project from working period 2 is to create two polynomials by identifying zeros, creating the factors, and multiplying them, and then verifying each one is in fact a factor of your new polynomial. So you have to create two using the following requirements. First, write it in factor form and then multiply it to get into standard form. One of them must be an odd degree, so that's at least 3 factors, and one must be an even degree, so that's at least 4 factors. One must have a positive leading coefficient and one must have a negative leading coefficient, so you will get to choose that a value. And one of the two, either your degree 3 or degree 4, must have a repeated root that repeats once. So the first step I would actually do is identify the zeros of the polynomial I'm going to create. So I'm going to show you an example where we create a 4th degree polynomial with one value repeating. So let's say that I want my zeros. Oh, well, that really jumped. Get rid of that and work a little more up here. Let's say I want my zeros, x equals 5, x equals -4, and x equals 3, and this one is going to be the one that's repeated. Right? You could have the repeated root in either your degree 3 or degree 4, but by repeating it now in my degree 4, I have 1, 2, 3, 4 roots. So these are my zeros. I could turn them into factors by taking their opposite signs. So x equals 5 is really a factor of x minus 5. X equals -4 is really x plus 4. And x equals 3 is really x minus 3, and it's repeated, so I'm going to put squared on that. I get to choose the a value, or the number that goes in front, and one has to be positive, one has to be negative between my two polynomials. So I'm going to choose for this particular problem a to be negative, and I'm going to choose -3. So that means in front of my polynomial, I have a -3, so this is either f of x or y equals all of these, and this is my factored form. Now I'm going to turn it into a polynomial in standard form. And to do that, I actually have to do all this multiplication. So I'm going to start with x minus 3 squared. So x minus 3 times x minus 3. Right? If I distribute, is x squared minus 3x minus 3x plus 9. So x minus 3 squared is really x squared minus 6x plus 9. And now I'm going to go ahead and rewrite everything else that was part of my polynomial. Now I'm going to take the next set of parentheses and distribute here. So I'm going to take the x and distribute it to all 3 parts. I'm going to take the 4 and distribute it to all 3 parts. Well, let's pretend that last arrow actually went where I wanted it to go. So now this doesn't get done anything with, but these I will multiply. So x times x squared is x to the 3rd. Then we have minus 6x squared plus 9x. And now the 4. It's positive 4x squared minus 24x and plus 36. So this set of multiplication turned into x cubed minus 2x squared minus 15x plus 36. And again, I'm going to bring down what I haven't multiplied yet, which is the x minus 5 and the -3. So now I'm going to distribute my x minus 5. So x will go to all 4 terms, and -5 will go to all 4 terms. So that's going to be x to the 4th minus 2x to the 3rd, and so on. So we're going to go ahead and multiply everything by x, and now everything by -5. So combining these, we get x to the 4th minus 7x to the 3rd minus 5x squared plus 111x minus 180. And I still have the -3. So the last thing I would do is I would distribute the -3. So my answer in standard form is going to be y equals, distribute the -3. So this is my polynomial in standard form. So the next part of the project is you're going to take the polynomial that you found and you're going to prove each of your original zeros is valid by substituting it back into it using synthetic substitution. And you have to do it for all zeros for each polynomial. So we knew that the zeros we had originally were +5, -4, and +3. Even though it repeated, we only have to check it once. And the polynomial I just got was -3x to the 4th plus 21x to the 3rd plus 15x squared minus 333x plus 540. So for each of these, I'm going to take the value here and do synthetic substitution. All right, so remember you multiply first and then add. I feel like I've already messed something up. Nope, I'm good. Sorry, I'm off. So then that is 225. All right, and I know that it in fact works because I got 0 as a remainder. So I'm going to do that for each of my zeros. And once I've checked all of them, I'm done with that polynomial, and I would work on my other one, right? Because you need 2 total, 1 degree 3, 1 degree 4, and overall you need to have it 1 positive a value, 1 negative a value, and 1 repeating overall. All right, and that is the project. That's all you have to do. All right, and let's say you saw me check the 3 also, and it worked, and that would be my project. All right, that is how you are going to do the marking period 2 project.